All right, so we are going to talk about the differential rate law, and we express the differential rate law using a rate law expression. And so in this section, we are going to determine the power to which each reactant concentration will be raised. Okay, so in other words, we're going to determine the order of reaction for each reactant. Right, so here's the equation we're going to use. And again, the only way to determine the order of reaction is to use experimental data. So here's my experimental data table that we're going to use. So if you want to pause the video and copy all of this down into your notes so that you have it to refer back to, and then I'm going to solve our problem. All right, so here is step one of my problem. We are going to find the order of reaction with respect to the ammonium ion, which is NH4 plus. So to do that, we are going to pick the two trials where our other reactant would have the same concentration. So in this case, NO2, so the nitrite ion, is the same. And we're going to find N. Right. Now here's what my rate expression would look like, right? It would be rate is equal to K times the concentration of my reactant NH4 plus raised to the order of reaction times the concentration of my other reactant, so NO2 negative 1, so the nitrate ion, and we're going to raise it to the power, we'll just label it M. Now I'm going to use two trials. So the two trials in my data table where NO2 has the same concentration is the third trial and the second trial. Now, by picking the two trials where the nitrite ion would be the same concentration, this allows me to cancel out the nitrite ion from my expression. And K is a rate constant, so it means I can also cancel this from my expression. And so we're going to plug in numbers. So the initial rate for trial number 3 is 5.40 times 10 to the negative 7. Rate 2 is 2.70 times 10 to the negative 7. And then concentration. So the concentration of the ammonium ion in trial 3 is 0.2 molar. And the concentration in trial 2 is 0.1 molar. Okay, so we're going to reduce. So we're going to take and we're going to divide our two rates, and we get 2. We're going to divide our two concentrations, and we get 2 raised to the n power. And then if I want to rearrange this so that n is no longer an exponent, the way we're going to do that is we're going to take the log of both sides. So we have the log of 2 is equal to n times the log of 2. And then we want n by itself. So we're going to divide both sides by the log of 2. And so n would be equal to 1. So now I know the order of reaction in terms of the ammonium ion. Okay, let's look at step number 2 in our problem. Now we're going to determine the order of reaction with respect to the nitrite ion. So for this, we're going to pick two trials where the ammonium ion has the same concentration. And we're going to find the order of reaction. So we're going to find M. So if I look at my data table, I can see that in trial numbers 1 and 2, the ammonium ion has the same concentration. So again, if I pick two trials where the ammonium concentration is the same, the ammonium ion concentration is going to cancel, the rate constant is going to cancel, and then I can plug in the data from my table. Notice that when I've made my ratio of my rate law expressions, I've always put the one that has the higher rate value first, so on the top of our ratio. So rate 2 is 2.70 times 10 to the negative second. Rate 1 is 1.35 times 10 to the negative second. Okay. In trial 2, the concentration of the nitrite is 0.010 molar. And in trial 1, it is 0.0050 molar. Okay. So again, I want to reduce. So if I divide my rates, we get 2. If I divide my concentrations, we get 2 raised to the m power. And again, if I want to rearrange this so that m is no longer a power, we're going to take the log of both sides. And then we want m by itself. So we're going to divide both sides by the log of 2. And so m is going to be equal to 1. Okay, so at this point, we can actually write our rate expression and be able to fill in the values of n. So rate would be equal to K times the concentration of the ammonium ion. And we're actually going to write the 1, so we know that it's first order. And the nitrite ion, again, we're going to write the 1 because we're raising it to the first order. All right. Now, we can actually find what we call an overall rate. And we find that by adding the orders together. So n plus m. So we get 1 plus 1. So the overall rate for this experiment would be a 2. Okay, so I'll put this as step number 3 here. All right, and then we have one last step that we can actually accomplish. We can actually, now that we have our rate law expression and we have some data, we can actually find the rate law constant. So we can actually find K. And you can use any of the trials that you would like to find K. I'm actually going to use the data from trial number 1 to find K. So I'm simply just going to plug in our data from trial 1 into my expression. So the rate was 1.35 times 10 to the negative 7th moles per liter times seconds. Okay, we're going to solve for K. The ammonium concentration was 0.1 molar. And I'm going to write this as moles per liter instead of molar so that we can look at units here, raised to the first order. And then this would be 0.050 moles per liter raised to the first order. So actually, there should be 2 zeros here, I think. There we go. All right, now numerically, I'm going to solve for K, and my numerical answer is going to be 2.70 times 10 to the negative 4th. But let's talk units. So here I would have gotten, if I multiply these together, we get moles squared per liter squared. And then I would have divided both sides by my moles squared per liter squared. So on this side, I have moles per liter times seconds. And when I divide, remember we can just flip this over, we get liter squared over mole squared. So here's how this reduces down, right? So my liters would cancel and one of my exponents would cancel. My moles here would cancel and one of my exponents would cancel. So we're left with liters per mole times seconds as my unit for K. So that's definitely one of the abilities you need to have in this chapter, is to be able to rearrange algebraically units to find the right unit for K, because it's not always going to be the same. All right, that is the end of our notes for how to find the order of reaction and problems related to the differential rate law.